On problem number 6, it says to use the given 0 to find the remaining zeros of the function. So it gives us the function h of x, which equals 3x to the 5th plus 2x to the 4th plus 60x to the 3rd plus 40x squared minus 375x minus 250. And it gives us the 0, negative 5i. Okay, to begin, let's remember that negative 5i is actually a complex or an imaginary 0, and all complex or imaginary zeros have a conjugate pair, which is like their opposite. So since this sign is negative 5, its pair is positive 5. So that gives us another 0. So to go about finding all the zeros of this, let's first write this in factored form, multiply it out, then divide it by this so that we can see what remains. Okay, let's do that. So we have put it in factored form. We change the signs, x plus 5i, it's that one, times x minus 5i, which is this one. So when we go ahead and multiply it out, we get x squared minus 5ix plus 5ix minus 25i squared. So the middle terms cancel. We're left with x squared minus 25i squared. Now remember, I squared equals negative 1. So we can substitute that in, and we get x squared negative 1 times negative 25, which is positive 25. Okay, so now let's take this and divide it by this to see what remains. So this is going to be a lot. I'm going to need a lot of room for it. X squared. When you're doing actual division of functions, you need to make sure that you have all the terms. So since this doesn't have an x to the 1, we have to put that in. So we have x squared plus 0x plus 25. I'm going to run out of room. And then we bring this down and put it inside of here. So we have 3x to the 5th plus 2x to the 4th. And inside of here, if it didn't have a term, you would need to put a 0x to whatever power. Minus 250 just fits. Okay, so now we need to first to begin. What times this x squared will get us 3x? Well, 3x to the 3rd times this will get us that. So let's put 3x to the 3rd. And then we multiply everything by this and put it down here. So we get 3x to the 5th plus 0x to the 4th, because we don't have one. And then we multiply this, so we get plus 75x to the 4th. And remember, we were actually subtracting that. So we go ahead and subtract. We get 0 here. We get 2x to the 4th still. That stays the same. And then 60 minus 75, we get negative 15x. Sorry, this is a 3rd to the 3rd. Okay. So now let's bring down our 40 and add it to that. And let's see what times this gets us 2x to the 4th. So 2 times x squared, okay, this times 2x squared will get us 2x to the 4th. So I add that up here, 2x squared, and now let's multiply it out. We get 2x to the 4th, then we get 0 plus 0x to the 3rd plus 2 times 50, 50x squared. And remember, we're subtracting all that. Okay. So let's go ahead and subtract. We get 0, negative 15 minus 0, still negative 15x to the 3rd. 40 minus 50 is negative 10x squared. Okay, and let's bring down this negative 35x. Like I said, I'm running out of room. Okay, so what times x squared will get us negative 15x to the third? Well, negative 15x will get us that. So, negative 15x to the third. Now, multiply this by the 0x plus 0x squared. Negative 15 times the 25. And that is actually negative, this is a 75. And that gets us actually negative 375x. So, when we subtract this, negative 15 plus a negative 15x, they will cancel, so we get 0. Negative 10 minus 0, still negative 10x squared. Negative 375 minus a negative 375, so that becomes a plus, and that will cancel, so we'll have plus 0x. Lastly, let's bring down this negative 250. I'm going to scoot over. So we have negative 10x squared plus 0x minus 250. Okay, so now what times x squared, running out of room. What times x squared will get us negative 10x squared? Simply a negative 10. Add negative 10 right there. Now let's multiply everything by that. Okay, so negative 10 times x squared, negative 10x squared. Negative 10 times 0x, 0x. Negative 10 times 25 gets us a negative 250. Now let's subtract that, and we get negative 10x minus negative 10x, going to cancel, 0x squared. 0 minus 0, still 0x. Then negative 250 minus negative 250, it's going to be negative 250 plus 250, so we get plus 0. So since this ended in 0, everything is zeroed out, this up here is our new equation, because there's no remainder. So now that we have that, now that we have taken basically the negative 5i and the 5i out of it, let's go ahead and use the the remainder, let's go ahead and use the rational zero theorem of this in synthetic division to find the rest of our zeros. So let me write our equation. Okay. So remember, the rational zero theorem is factors of the constant over factors of the leading coefficient. So we have 10, 3. What are some factors of that? We have 1, 2, 5, and 10. 1 times 10, and 2 times 5. And then 3 is just 1 and 3. So our actual possible rational zeros are plus minus 1 over 1, 1, 2 over 1, 2, 5 over 1, 5, 10 over 1, 10. Then we do it with the 3, 1 over 3, 1/3, 2 over 3, 2/3, 5 over 3, 5/3, and lastly 10 over 3, 10/3. And don't forget that each one could be a plus and a minus. So now, let's go ahead and do synthesis division of one of these. Let's go ahead and try negative 2/3. Yeah, let's do negative 2/3. Okay, so we get all the leading coefficients of the terms. So we put a 3, a 2, a negative 15, and a negative 10. And first we pull down our 3. Negative 2/3 times 3, the 3's will cancel and be left with negative 2. 2 plus negative 2, 0. Negative 2/3 times 0 is 0. Negative 15 plus 0, negative 15. Negative 2/3 times negative 15 is positive 10. Negative 10 plus positive 10, 0. Since that's a 0, this right here is an actual 0 that we want for our function. So now let's go ahead and what can we do with this? We could try to do synthetic division, but let's go ahead and pull it out as a function, and maybe we could break it down some more, or maybe we'll need to apply the quadratic formula. So we get 3x squared plus 0x minus 15. We could factor out a 3, but we can't break that up anymore. So let's go ahead and apply a quadratic formula to actually this. Okay. Quadratic formula was negative b plus minus the square root of b squared minus 4 times a times c. And that's all divided by 2 times a. So remember, the 3 is our a, the 0 is our b, and the negative 15 is our c. So let's plug that in. We have negative 0 plus minus the square root of 0 squared minus 4 times a, 3, times c, negative 15. That's all divided by 2a, which is a is 3. So, okay, our zeros will cancel because they're zeros. There's no point in dealing with them. And then let's multiply out the inside. Okay, sorry for that pause. I was sort of lost in my thought. Okay, so negative 4 times, when we multiply out the inside, we get positive 180. So we have the square root of 180 plus minus, and then we divide that by 6. Okay, let's break 180 up. Okay, if we break 180 up, let me pull this. Okay, so using my method or Miss Keenan's method, they both work. 180. It's even, so let's divide it by 2. We get 90. Break 90 up, divide it by 2 because it's even. We're going to get 45. Let's divide 45 by 5. And, okay, so divide it by 5, and we get 9. 5 can't be broken up, but the 9 can be broken up into 3s. Okay, so now since we have a square root, can we group anything? We can group the 2's because there's 2 of them, and we can group the 3's because there's 2 of them. So on the outside we will have 2 times 3, and on the inside we will have the square root of 5. Sorry, 5. Okay, so that becomes, remember, let me put it back onto our actual quadratic. So it's plus minus 6 square root of 5 over 6. Now let's cancel the 6's, and we get plus minus the square root of 5. Okay, so after all that work, this is 2 zeros. So now let's go back and collect all our zeros. We know that okay, these are our zeros. We have negative 2 over 3. We have negative square root of 5. We have the square root of 5. But then also remember that we found our conjugate pair, which was a 0. So 5i. And you would input that as your answer. Those are the remaining zeros that you found.